Oh, charge. Charge. An object or atom or molecule gets by losing losing or gaining electrons, by losing or gaining electrons, right? So if an if you rub, this is silk silk cloth, and there is a glass rod, glass rod, right? So what happens? This is silk and this is glass rod. Glass rod, on rubbing, glass rod get positive charge by losing losing electron, and silk get negative charge by gaining electron, by gaining electrons, right? Similarly, if you take here wool, this is wool, and there is this is rod of umber, ebonite rod, ebonite, right? So this ebonite rod get negative charge, negative charge, negative charge by taking electron, and wool positive charge by losing electron, losing electrons, right? So what I said, this glass rod loses electrons. Electrons are coming here, right? It gets positive charge. Electrons are coming out of it. Electrons are coming out of it. So it gets positive charge, and it gets negative charge, right? And here electrons are moving. Electron, ebonite rod get negative charge means it absorbs electrons from wool, right? This is negatively charged, so that it gets negatively charged, and this gets positive charge, right? So this is known as, this is called static electric electric current. Static electric current, this is all about, right? Now, should I rub? This much you understand, na? Glass is losing, so get positive charge. Silk is gaining, negative charge. Ebonite is taking electrons, negative charge. Wool is giving, so get positive charge, right? Okay. Now, current is rate of flow of charges. Electric current is electric current is rate of flow of charges. Rate of flow of charges. Oh, rate of flow of charges. Charges. Right? This is. So I is equal to Q upon T. Right? Where its unit is coulomb. This is ampere. This is second. And this is we called ampere. Ampere. So 1 ampere is equal to 1 coulomb per second. 1 coulomb per second. Right? That is equal to 1. So rate of flow of charges, I is equal to Q upon T. Q can be written as, Q is equal to number of electrons into charge on an electron. This is, the N is number of electrons, and this is charge on an electron. Charge on an electron, right? So charge on one electron, charge on one electron is equal to 1.6 into 10 की power minus 19 coulomb. Right? This is charge on one electron is 1.6 into 10 की power minus 19 coulomb. For, right, negative charge. Electron, so it is negative. Right? Now, conventional electric current, conventional electric current flows from positive terminal to negative terminal or or opposite to the opposite to the flow of opposite to flow of electrons, right? Opposite to flow of electrons, that is direction of conventional electric current, right? Always opposite to the flow of electrons. It is like that. If these are atoms, right? So it is giving one giving one electron to this, so it gets positive charge, it gets negative charge, right? Again it gives one electron to this, so it gets positive charge, it gets negative charge. It gives electron to this, so it gets positive charge, it gets negative charge. It gives electron to this, so it gets positive charge, it gets negative charge. It gives electron to this.
Positive and negative.
No. It loses one electron, so get positive charge. It loses one electron, get positive charge. It loses one electron, it gets positive charge. It gets negative charge. It loses one electron, it gets positive charge and gets negative charge. It gets positive charge, right? It gets negative charge. When it loses electron, it gets positive charge, it gets negative charge, right? So what you have seen?
Transferring of electrons.
Positive charge is moving in this direction. It is getting positive charge. When it is giving electron, it is moving to positive direction of positive charge, right? This is, it is moving in this direction, right? And electrons are moving in this direction. Electrons moving electrons direction. So positive charge direction, this, electron charge direction is this. So they are opposite to each other. And this is known as direction of flow of conventional electric current. Yeah? Conventional electric current. Right? Do you understand this?
Yes.
Okay. Should I rub?
Yes.
Okay. What next we have?
A set of potential.
Potential difference. This is a charge Q. So there will be electric charge, so there will be electric field around it. Electric field around it. This is what? Electric field around a charge, right? And there is unit test charge. This is positive unit test charge, right? This is, and distance between them is infinite. D is infinite. Distance between the unit test charge and the charge is infinite, right? So to bring amount of work is done, amount of work is done to bring unit test charge from infinity to within electric field known as electric potential. Electric potential. Electric potential, right? Electric potential. Amount of work is done to bring unit test charge from infinity to within electric field is known as electric potential. W is equal to E is equal to W upon Q. What?
E is equal to W upon Q.
Amount of work done to bring unit test charge within the electric field. It is known as electric potential. Now, when this charge comes here, so it is positive charge. So bringing it here or bringing it towards here, right? This is called amount of work done to bring change in position of an object within electric field known as potential difference. Right? What I said? Amount of energy to bring. This is also V is equal to V is equal to W upon Q. Right? This is This is joule. Sorry. This is joule. This is coulomb. This is volt. So 1 volt is equal to 1 volt into coulomb. Coulomb is equal to 1 joule. Ready? 1 volt into coulomb is equal to 1 joule. V is equal to W upon Q. Its unit is volt. Its work unit is joule, and charge unit is coulomb. Right? So 1 volt is equal to, you can write joule per coulomb. You may write 1 joule is equal to 1 joule. 1 volt. 1 volt is equal to 1 joule per coulomb. Yeah, 1 joule is equal to 1 volt coulomb. Right? You have read 1 electron volt. 1 electron volt. Right? So it becomes 1 into an electron is having a charge of 1.6 into 10 to the power minus 19 coulomb into V is volt. Right? Coulomb into volt is joule. So it is 1.6 into 10 to the power minus 19 joule. Right? That is equal to 1 electron volt. That is equal to 1 electron volt. 1.6 into 10 to the power minus 19 joule. That you get? Right? Now we have Ohm's law. Ohm's law. What is that? At constant temperature, potential difference is directly proportional to directly proportional to I, electric current. Just check your book, electric current. I get little confused. So we can say V is directly proportional to I. Right? If we remove this proportionality sign, we write it V is equal to Ri. This R is known as constant. This is constant, which is equal to resistance. Right? This is known as V is equal to I, which is known as constant, and it is resistance. Right? So we have Ohm's law is basically Ohm's law. We can write V is equal to IR. V is equal to IR. Getting? This is we have for Ohm's law? It is. Huh?
Yes.
Okay. Should I run?
Yes.
Ohm's law. Now we talk about resistance. Resistance is resistance offered by the conductor conductor regi- resistance obstruction obstruction offered by the conductor in the flow of charges. Flow of charges. Obstruction offered by the conductor in the flow of charges, known as resistance. Right? Resistance flow of current in a circuit in a conductor depends on number of valence electron present in valence shell. Right? What I said? Flow of current in a conductor depends upon number of valence electron present in valence shell. Valence shell. Right? If number of valence electrons are more, resistance is less. If 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 number of valence electrons is more in valence cell, resistance will be less and what current flows more, current flows more, right? Unit of resistance is equal to ohm. right? Now reciprocal of resistance is known as conductance. Conductance. Reciprocal of resistance is known as conductance. So R is 1 upon C, or C is 1 upon R. So unit is omega per ohm. Omega per omega, yeah, per ohm. This is conductance. This is we called conductance. It is reciprocal of resistance. Reciprocal of resistance is known as conductance. If resistance is more, conductance will be less. If conductance is more, resistance will be less. So its unit is per ohm. Right? Should I rub this?
Yes.
This much. Okay. Now resistance is directly proportional to length, means length of conductor and directly proportional to area. मतलब area of cross section. Area of cross section of conductor so R is directly proportional to L upon A. If we remove this proportionality sign, then we write R is equal to rho into L upon A. You know what is L? Length of the conductor. It is area, is cross section area of conductor. Conductor is generally cylindrical, so इसका area may be generally pi r square. Cylindrical होगा ना, so front face जो होगा वो जैसे जैसे ये we have this pen, it is in cylindrical in shape, so this area, this is circular, so area of circle, the area of circle is pi r square, so that's why it is pi r square. So this is we have and this is called, this we called constant of resistivity. Constant of resistivity. Resistivity, constant of resistivity. This is known as constant of resistivity, right? So R is equal to rho into L upon
A.
A. This is constant of resistivity, or we call resistivity. Resistivity, right? So rho is equal to R into A upon L, right? So this is omega into meter squared upon meter. Cancel out, so omega meter. This is unit of resistivity. Right. Now, reciprocal of resistivity. Reciprocal of resistivity is known as reciprocal of resistivity is known as conductivity. Conductivity, right? So sigma is equal to 1 upon rho. You get that? So it is what? 1 upon omega meter. So you can write per omega per meter. It's unit of resistivity, conductivity. This is known as conductivity. Getting? Okay. Should I rub?